A major solar storm is happening now. This is a powerful geomagnetic storm. It truly began to unfold around June 1st, 2025. We experienced a severe G4 level storm then. That was quite a show for many skywatchers. Tonight, Monday, June 2nd, keep your eyes on the sky. More northern lights are highly possible. They could dance across the United States. This is an official Aurora alert, so don't miss out. Our planet is receiving a cosmic light delivery. Earth's magnetic field is currently buzzing. It is reverberating from a massive solar impact. This impact occurred in the early hours of June 1st. Think of it like a bell being struck. Our planet's magnetic shield is still ringing from it. This ongoing activity is what fuels the aurora. The solar particles continue to stream towards us, igniting the sky with beautiful, shifting colors. It is a dynamic and evolving space weather event, a fascinating display of natural power. The solar storm that hit us was impressive. The material that arrived on June 1st was fast. It was traveling at incredible speeds, around 1,938 kilometers per second, in fact. That is roughly 4.3 million miles per hour. This was not just a simple, single blast either. It was a complex event, quite fascinating, made up of material from multiple solar eruptions, all compressed together into one potent structure. This complexity means the effects can linger. So tonight, June 2nd, is very important. The show might not be over yet. We are still under an aurora alert. The conditions remain favorable for sightings. If you missed the lights on June 1st, don't worry. You might have another fantastic chance tonight. The energy from the initial impact is still present, and more solar material could be on its way. This is a prime opportunity for skygazers. Prepare for a potentially stunning celestial display. What causes these amazing light shows? Often it starts with a coronal mass ejection. We call this a CME for short. Imagine our sun letting out a giant sigh. But this sigh is made of superheated gas. This gas is called plasma, full of charged particles. It also carries parts of the sun's magnetic field. These CMEs erupt from the sun's atmosphere. They then travel outwards through space. Sometimes they head directly towards Earth. The CME that struck us on June 1st was a big one. It was a significant solar eruption. As I mentioned, its speed was truly breathtaking, very fast, nearly 2,000 kilometers every single second. This particular event was also quite complex. It wasn't just one cloud of solar material. Instead, it seemed to be several CMEs, all bundled and compressed tightly together. This makes its impact on Earth more prolonged and potentially more interesting to watch unfold. But CMEs are not the only solar factor. Earth is also being buffeted by something else. This is high-speed solar wind. This wind streams from holes in the sun's corona. These are called coronal holes appropriately enough. Think of them as openings in the sun's atmosphere, allowing fast solar particles to escape easily. This solar wind adds to the geomagnetic disturbance, working alongside the CME's impact. It helps keep our magnetic field unsettled. So, how do these solar events create storms? When a CME or strong solar wind reaches Earth, it slams into our planet's magnetic field. This field is called the magnetosphere. It acts like a protective bubble around Earth. The impact can cause this bubble to shake. It transfers energy and particles into our system. This disturbance is what we call a geomagnetic storm. These storms are rated on a G scale, from G1, minor, up to G5, extreme. As a space weather physicist, I am watching closely. We just entered what looks like the core. This was from the first main structure, the structure that hit us on June 1st. But this storm is very complex, remember. It is comprised of material from multiple CMEs, all compressed into one composite structure. This means there is a chance for more action. We might see more than one core signature. The storm's behavior is still unfolding dynamically. Because of this complexity, the show can continue. There is a chance this storm could still give us a display. Perhaps a waning show, but a show nonetheless, even 24 hours after the first core hit. That means tonight, June 2nd, is still promising. The energy levels might still be high enough for visible aurora, especially in darker skies. So do not assume the best is over. The sun often has a few surprises for us. We must keep observing the conditions closely. And there is more news for aurora chasers. Another, albeit smaller, CME is on its way. It is currently heading toward our planet. This second CME could stir up activity again. We expect it to arrive fairly soon, likely around late on June 2nd or possibly into the early hours of June 3rd. This could extend the viewing opportunities, even if it is not as strong as the first. Every solar input offers potential for lights. My prediction for this second incoming storm? It is expected to arrive late on June 2nd. This could potentially cause storming through June 3rd UTC. However, I anticipate the aurora chances will be weaker. Compared to the G4 storm we just had, we are likely looking at a G1 to G2 level storm, perhaps by midday on June 3rd UTC time. A G2 storm is still very exciting though. It can produce beautiful auroras at high latitudes, and sometimes even dip into mid-latitudes. So how do these CMEs actually create auroras? It is a beautiful dance of particles and magnetism. CMEs carry those electrically charged ions I mentioned. When these ions collide with Earth's magnetosphere, they can trigger these geomagnetic storms. During the storms, many particles are trapped. They are then guided by Earth's magnetic field lines. These lines channel them towards the north and south poles. This is where the magic truly begins to happen, concentrating the solar energy in these regions. As these charged particles funnel downwards, they speed into Earth's upper atmosphere. Here, they collide with gases like oxygen and nitrogen. These collisions excite the atoms and molecules of gas. When the atoms and molecules calm down again, they release this extra energy as light. This emitted light is what we see as the aurora. The northern lights, or Aurora Borealis, and the southern lights, or Aurora Australis. Different gases give different colors, like green or red. What about visibility for tonight, June 2nd? And possibly into June 3rd from that second CME? If we reach G2 storm levels, that is good news. Auroras could potentially be visible further south, perhaps as far south as New York State, and even Idaho, under the right conditions. This typically means around 55 degrees geomagnetic latitude. So if you live in northern US states, be alert. The chances are definitely elevated right now. It is worth taking a look outside after dark. So my final message is this. Look up tonight. This is a wonderful opportunity to see the aurora, to witness this cosmic spectacle with your own eyes. For the best viewing experience, find a dark location. Get away from bright city lights if possible. Face towards the northern horizon and be patient. Sometimes the lights can be faint at first, or they might burst forth in vibrant displays. Wrap up warm, bring a friend, and enjoy the show. Nature's grandest light display might just perform for you.